Hello everyone and welcome to Explore Engineering. Have you ever wondered how your Arduino UNO talks to your computer? Communication is the key to every smart electronic system, and in this video we'll explore the power of communication using Arduino UNO. Whether you want to print simple messages, monitor live sensor data, or understand one of the most important tools for debugging and data transfer, you are in the right place. Now you will learn how Arduino sends and receives the data in a simple, practical and easy to understand way. So let's get started. Here in this program, that is this Arduino program, it demonstrates the serial communication and digital output control by alternately turning two LEDs, that is we are using here green and red LED, on and off every second while displaying their status on the serial monitor. So here you'll get like this message in the serial monitor and the LED will glow alternately on and off. And the Arduino UNO, it controls the LEDs through its digital output pins. At the same time, it sends the text messages to the computer using the serial communication so that the user can monitor what the program is doing. Now here, why we are using this program? Here, by using this program, we'll learn how to control output devices using Arduino. And we can understand the use of the setup and the loop functions. And also we can practice serial communication for debugging and monitoring. And we can understand the use of the digital write, then pin mode and the delay instructions. So it is the basic concept behind the traffic lights, warning indicators and many embedded systems. Now we'll look at the code here. First you have the wide setup. So this wide setup function, it runs only once when the Arduino is powered on or reset, and it is used to initialize the settings. Next is serial begin 9600. So here it starts the serial communication at 9600 baud rate. Okay, so it starts a serial communication between the Arduino and the computer, and 9600 is the baud rate. Baud rate means the data is transmitted at 9600 bits per second, and this allows the messages to appear in the serial monitor here. Now next you have the this one, serial.println. I have written my name here, Feroza. So this will print the name or any of the word which you view on the serial monitor, and this println, it prints the text and then moves the cursor to the next line. So if you don't if you want to go to the next line, you should write it as println. Otherwise you can just type it as serial print. Okay, here we have not used any ln. Here we have used the ln because you want to go to the next line. Then next comes the setting of the pin modes. So here we are using the pin mode 7, output, pin mode 8, output. And this will configure the digital pins 7 and 8 as the output pins. Now since the LEDs are connected to these pins, Arduino sends the high and low signals to control them. Okay. Next, we have the wide loop. So this wide loop, it runs continuously after the setup, and the instructions inside it, it will repeat forever until and unless we stop the simulation. Next is turning off the LED on, and that is green LED on and red LED off here. Now here what we are writing is digital, this one, okay, this one, digital write 7 high, digital write 8 low. So high provides approximately 5 volts, okay, here, and turns the LED on, and low, we are writing here the low, okay, that is the value, we are writing it as low. So low provides 0 volt, turning the LED off. Now one thing you have to remember is this Arduino program is case sensitive. You have to carefully write the functions here. See, this is small d, and here for write it is capital W. Now when you're writing the serial print, here it is capital S and here it is small p. If you write this as capital P, then you'll get the error. So you have to carefully write because it is a case sensitive. Next, when you execute this, what you will get? You will get the green LED on and red LED off. Here, green LED is on and red LED is off. Then, after that, what we'll do? We want to display the status. So this is displaying the status here. Display the current LED status in the serial monitor. Okay, this is the serial monitor and it will display the current LED status. Now print here. This print is there, so it will continue on the same line, and print ln, it will move the cursor to the next line. That is green LED is on. Okay, then I have put a comma here, comma. Now after this, the next line, it will be in the same line here, but here we have written it as ln. We have used this function, so automatically the cursor will go to the next line here. What will get the output? We'll get the output it as next. Okay, for the next line, we'll get the output as green LED is on and red LED is off. This is the output for this one, first one. Okay, these instructions. Next, it will wait for 1 second, 1000 millisecond. It is 1000 millisecond. It means it is 1 second. Okay, that is, it will pause the program for 1000 millisecond. That is 1 second, and this allows the LED state to remain visible before changing. Now what we want to do? We want to reverse it. Now we want to reverse the LEDs. That is, we want to make the green LED off and red LED on. So here digital write 7, low. Earlier what we have done? 7, high. For the green LED, we wanted to on this. Now we want to make it as off. So we'll write it as low. And digital write 8, high. So now the red LED is connected to pin 8. The green LED is connected to pin 7. Now here we are making the red LED as on. Then we'll display the status, that is updated status. So what it should be? Green LED is off, red LED is on. So green LED is off, red LED is on, and this will again wait for 1000 millisecond, and again this will be continuing. That is, you will get alternating messages. Green LED is on, red LED is off, green LED is off, red LED is on. Okay, so this is the program. What is the working? The program alternately turns on the green LED and off the red LED for 1 second, then turns off the green LED and on the red LED for 1 second. And this continues indefinitely, so the LEDs blink one after the other. So this is the program and this is the connection what we have to do. You can see here I am using here 2 LEDs. One is green LED, one is red LED. One is green LED, another is red LED. And here both are grounded here to the ground pin, and we are using the resistors of 1 kilo ohm at the anodes of the LEDs. Okay, and here red LED is connected to pin 8. Okay, this one, pin 8, and green LED is connected to pin 7. Now here the applications of the serial monitor is, it is used in traffic light systems where the LEDs are used to control traffic signals, ensuring smooth and safe movement of vehicles and pedestrians. Then it is also used for status indicators in electronic devices. That is, LEDs show the working status of devices such as power on, charging, data transfer, errors, or the alerts. Then third is the industrial machine status monitoring. Here the LEDs indicate machine conditions like running, stopped, fault, or maintenance required, helping in easy monitoring. And fourth is learning embedded systems and the Arduino programming. It will help the beginners to understand the basics of the digital outputs, logic control, timing, and programming in a simple and effective way. And last is the LED blinking and debugging practice, where the LED blinking, it is a simple way to test and debug the code, checking the connections and confirming that the program is working as expected. Okay. Now we'll go to the Tinkercad and we'll execute the program and we'll make the connections. So here already I have done the connection. You can see here. Okay. I will do the connection once again. So I'm taking a Arduino UNO board. Then I want two LEDs. I'll select one more LED and one more LED. I'll make the second LED color as green. Okay, green. Fine. Now I have to connect first both to the ground. Okay, like this. I'll change the color of this to black because it is ground. Now again I'll take the connection here and I'll connect it to ground here. Right. Okay. I'll connect it here to ground. Hmm. Fine. Next, what I have to do, I have to use a resistor and I have to connect it here to the anode of the LED. Okay. Now the red LED is connected to 8 pin number. So I'll connect it to 8 pin number like this. Then green LED is connected to 7. I'll connect it to 7. So this is how you have to make the connections. Okay. Now I'll remove this. So this was the connection to show. Okay. Now we'll go for the code. So this is the code which I have copied here. Okay. Now I will start the simulation. Start the simulation. See, it is continuously printing. First it is printing Feroza. Okay. It has printed Feroza. Now here you can see the alternately blinking the LEDs. That is, once the red LED is blinking, after 1 second delay the green LED is blinking. Okay, I'll stop it and I'll start once again. You can see first the message Feroza is printing. After that you can see green LED is on, red LED is off, then green LED is off, red LED is on. So I'll start the simulation once again. See. Okay, here. You can see the LEDs glowing alternately with a delay of 1 second. Fine, I'll stop the simulation. So this was about the serial communication using the two LEDs. That is this is that's how easy and useful serial communication is with the Arduino UNO, and it forms the foundation for debugging, monitoring and exchanging the data in almost every Arduino project. And you need to try this program, experiment with different messages and build your confidence in Arduino programming. If you found this video helpful, please like, share and subscribe to the channel for more Arduino and electronics tutorials. Thank you for watching. Keep learning, keep experimenting, and I'll see you in the next video. Happy coding.